Hello, welcome back to BlenderSushi. Um, Today I'm gonna continue with our last topic. It's the Phyllotaxis thing, and this is part 3 of the series. The live nodding we did last time were it's all about optimizations. So for example, I made these 3 flowers each with slightly different color. And let's see the node 3. So this is what we got. So this is like the whole node 3 setup, and then we created group. We call it sunflower, but it's more like maybe water lily, or I don't know, maybe chrysanthemum flower. I don't know what it is, but anyway, they're like flower looking. And so with the group node we can have this 1, 2, 3, and I talk about how we could approach this if we were to make like 1,000 or 10,000 instances of this flower setup. How would you do that? In theory, I think it's quite possible to actually create a loop where we have like a 1,000 or unlimited variations for each flowers. But then again, I think that's not very efficient after all. You probably just want to maybe bake out 10 or 20 different variations of the flowers, bake it out, bake the animation as MDD point cache, and then bring it back into like a fresh scene, etc, etc. I will do exactly that now. Okay, so let's start with last time I left you with this kind of like linear animations. Of course you can make more variations for each petal. I'm not gonna do that. Maybe I'll just turn this linear into back. I think back is nice. It gives this slight more natural motion. I will I'm thinking to bake just 1 flower for now. I can make 3, but it just take more time. I'm just gonna bake 1 flower, and for you, so you understand how the process of baking. I've done this only a few times. Hopefully it's working as planned. So I'm gonna save this as version 3x001. Okay, save. So let's just focus on this 1 flower, which is this one. Let's see, we need to go back to the loop, and last time I left you with this object output. We actually want to join this into a single mesh and then bake it out as a single mesh, and that's more manageable. So from here I'm gonna get the object mesh data. I think I'm doing it correctly, like this. So plug that in. We're still let me check. So it's not always calculating. That's alright. And I'm going to output. Let's see what can we output here. New generator output. If I type in mesh, so we can output, okay, mesh data list. That should be okay. Mesh data list. Mesh data, object mesh data. Let's see if we can just plug that in. Okay, good. That's good. We probably don't need the edge indices. So just the vertex location, polygon indices. Animation node will handles the mesh data. So if we also plug this into the group output, hopefully we get what we want. So just focus on this yellow flower. We have object list and mesh data list, and so if we output the object mesh data list, mesh data, create a new target object, turn on the mesh data, and if we plug it in, maybe it's not gonna work right away. We need a maybe join mesh data list. So I believe the mesh data list currently have the information of each petal, the position of the vertices of each flower. If I plug this into that guy, now we have the data of the whole flower. I think that should be it. So there you go. Probably it's a good idea to have like a visibility control of the object as well. Let's see, object blah blah blah. So with this approach, procedural approach, we can always go back and adding more or maybe reducing. It's depend on the need. Visibility object, visibility output. So for our object, if we plug that in, turn on the hide and unhide. There's a boolean data, and I need to connect. Let's see if I can connect this into that guy. So that's quite nice to have. So hide is a new parameter. Let's call it, okay, just call it hide. So we have the visibility control for each of the flower. Okay, that's also nice to have. So I'm hiding the yellow flower, and we just have this mesh. And the good thing is it's still actually animating. Let's save this real quick. So that's a good start. It's becoming it's becoming a single mesh, and then let's see how many frames we're gonna bake this. I think 250. We don't need to worry about the frame range, I guess. Okay, we're gonna just bake it as MDD point cache. I think I'm going to go to the beginning of the animation. So frame 1, frame 0 is good, and then if I go lower, see, we have like a totally 0, and that's actually what we want. I believe this is gonna work, so we just gonna do file export as wavefront obj, and let's see, go to desktop, and then maybe flower, call it flower 001. You might have variations of flower, and we want to export selection only. We don't need animation. OBJ cannot have animation anyway, but it might output like sequence of OBJ. We're gonna leave the forward Z and up, Y up. I'll leave it at the default. It might be wrong, but it's okay. And turn on keep vertex order, because we don't want Blender to export out and sorting the vertex order. So that's the important options. And let's just save it out. Export OBJ. Looks like there is nothing, but it's actually, we have all the vertices there. Now, next we're gonna export the MDD. We don't have the export MDD yet, so go to user preference, and then in the add-ons tab, just search MDD. We have import export new text MDD format. I think that's from Lightwave, and this actually comes with Blender. It's always there, just nice. And then we get file export MDD Lightwave point cache. Okay, that's our animations for the flower, and that's my test file. I'm gonna export flower1 MDD. Export it out. Frame per second 24, start frame, end frame 500. So that's it's been taken care of. So we're just gonna wait for a few seconds. Hopefully it's calculating all right. I think it shouldn't take too long. Let's wait. Let's check it out. OBJ export finish. Flower MDD. Let's check it out. 217 kb. 217 kb. It's a little bit odd. Maybe I'll try again. It should only take like a few seconds. Let's reopen Blender. I could use the one I baked out earlier, but I'm just curious with that. Let's see. Open recent. There, this guy. Maybe I shouldn't go too far. So just from here and then file export MDD. So MDD file export MDD desktop flower. So it's probably baking correctly. Probably just need to be a little bit more patient. Maybe while it's baking, we open another Blender. I think that should be fine. So let's just continue to bake, and we are opening another Blender. Okay, we have another Blender open. I can actually, I'll just gonna import my previous baking, keep vertex order, desktop. So I'm gonna use this water lily, import. So it's looking like that. And I'm gonna select this guy and then go to the modifier. I really like this modifier and mesh cache thing, and it's gonna load the MDD animations. And then go to desktop and then find our MDD. See if we can filter this out. Oops, no. Yep, that guy, accept. So we have our MDD. So we have the animations happening. Alright, that's all good. So that's all good except that somewhat with a default MDD, I'm always getting this like a wrong orientations. I found that quite strange, but that can be easily fixed by using one of these axes. So the up axis should be the forward axis, up axis, flip axis, not flip axis, forward and up, maybe X and Y, X and Y, maybe plus X plus Y, X and Y. That looks pretty correct to me. Yes, that should be good. I'm gonna save this as this version 3. So we have, you see how we have our animation bake and we don't have our compositing node. It's all empty at this moment. So it's just the animations, right? This is like super fast as well. You can scrub this and then this is the whole animations, which is really nice. Really, you have the flower animations there and you can just render it out. But if you have to take care of a few things like the material is gone because it's an MDD point cache. I'm curious to find out how to transfer the color into here, because previously we were using animation nodes and then for each petal we are coloring the object color. Now that we join the whole mesh, we lost all the informations and we kind of go back to square, like back to 0. And because this is a single object, maybe you cannot use animation nodes to color it. You might need to use Sverchok or other method. There must be a way to bake or transfer the data. Yeah, that's okay. I'll take care of that later. For now, we're gonna investigate this mesh cache modifier a little bit, and we're gonna use animation nodes to instance this flower. So maybe have like a couple. So here we have a lot of options with the time mapping. The one I like is the time and custom, I think. So time and custom, frame and custom. Actually, frame and custom is kind of nice as well. Or a factor. With a factor, you have like 1 to 0 to 1. 0 to 1 for the whole frames. Yeah, instead of scene, I'm gonna use custom and then the frame. I think I can use the evaluation frame. That should be alright. We can change it anytime. Let's save this. Save new version. Let's go to animation nodes. We're gonna colorize it using Sverchok a little bit later. For now, just switch to animation nodes and create a new. What are we going to do with this? This is gonna be the instance object. Let's check our Blender. So this is actually finished baking as well. So this is actually good. So the baking is working. I'm gonna quit this. Back to this guy. Let's see where we're up to. Okay, object instancer. Object instancer. Let's turn off always. Let's grab this guy. This is going to be the master. That's the master. How many instances? It depends on how many points we want to have. We can try the line mesh for now. We know that we're going to loop the object instance, so tap W, loop through objects, and we're gonna use the object transform output. We're gonna locate this the instance. We're gonna need to vector list. So the vertices of line, let's just plug that in. How many? We have 2 points because it says 2 steps. Plug in the vertices into the instance, and then it knows, okay, generates 2 different generates 2 copies of these objects. So let's have a look. Is it working? It's not calculating. I need to turn this on. And let's see, did I forget anything? Okay, the line is doing something. Oh, I know. Oh, I know. So that's the copy. We can't see it because the modifier is not on for the copy. We gotta turn on copy full objects and deep copy as well. So now we have 2 copies of the flower. There, like that. We can have multiple. They are not animating yet, but this is a good start. And we can have multiple. Instead of duplicating it on the z-axis, we want it to be maybe on the y-axis, like that. That should be good. 30. That should be good. It seems to be a little bit rotated. Yeah, because the way I bake it. Doesn't matter. We can randomize the rotation, randomize the scale. Doesn't matter. For now, we only care about the animations. As we already know, we can control the attribute of this modifier using animation nodes. So that's really handy. Object attribute output. So for each object, which attribute we want to control, just get it from here. Evaluations frame, right click, copy data path, paste it here. Let's have a look. What is this? Modifiers mesh cache. Okay, that's the name of the modifier for each of copy. Eval frame is the name of the attribute. And then, so the value, what's the value it's gonna be? It's gonna be like a float input. Test it. Okay, seems to be working. This is the master object. Master can be watching on the side. We care only about the instance. So as we can see, it's already working, which is really nice. The frame number, let's take care of this. You know, we can drive this using frame. Okay, you see how fast and interactive this is. It's really nice. Let's turn off the relationship lines, because they're gonna be annoying there. Tap U, hide relationship lines. Okay, good. Frames, and then you already know how to delay the animations, kind of like randomize where the animation is gonna start and it's gonna end. Let's delay that. Delay time. So delay time is good. We can have that. Plug in the index. If we use the index, then it's gonna stagger a little bit. Let me try just to show you, to be really clear. I'm gonna repeat this again and again. 20 times in each index, so you see how it's growing one by one. That's nice. The more you add randomizations, the more natural it's gonna be. Like even if you just rotating this guy, it's kind of funny that they suddenly rotating in the wrong way again when I did that. Random healer. Let's try. Index plug into the seed. So there, I don't know, the orientation is a little bit weird. We can always fix it inside the loop. Healer math. Rotate it in the, just do it like that. Minus 90, and then randomize the rotation slightly. Okay, that doesn't matter. We can further randomize the objects. For now, the animation is kind of taken. It's all good. It's been taken care of. This guy. Interesting. When I hit tab, it's just become like a dot. Yeah, that's alright. So we have that happening. We can also use things like grid instead of line mesh. Grid mesh, vertices, release, grid. How many? See, it's gonna grow. It's n 1000. See, it's really fun. So I'm kind of happy with this result. I didn't think I'm gonna go this far. That's nice. See how it's rotating slightly, and you can randomize the scale. Really, really nice. Let's have a look with the lighting. Sometimes I often use the matte cap because they look really fancy like that. So instead of staggering, you can also use the noise. You can actually use wiggle to randomize the order or something. So time delay, instead of the index going in, We can further randomize it using random number. This can be between 10 and 60. Just generate random number and multiply. So we're multiplying this with this. Add. So this, add that. Plug into delay. It's like randomizations. It is minus. So more random, but still have the order. And this is really fast. You can have more and less, and it's gonna continue to generate the number for you. Let's hide the master into a different layer. That's good. Okay. Before I go too far, let's make it 3 by 3. Now, what are we missing? Of course, the color. Yeah, the color is an interesting problem. Maybe I'm gonna do it. I'm gonna use a Sverchok. Sverchok has this Vertex Color node, and at this moment, this Vertex Colors, with this Vertex Color, we don't have the object in slot, but I believe there is an update with Sverchok coming soon where we can have like multiple objects selected, and then we just gonna generate different color. Anyhow, for now we can color the objects one by one and have a look. Let's switch to cycles, because Vertex Colors will work for cycles, not for Blender render. Let's select one of these, water lily, this guy, number 1, instance number 1, water lily number 1. See, we don't have this vertex color generated yet. Soon, very soon, once we create a color, vector color, vector in, plug that in. So say 1. So this is gonna be color red. So we have the SVV color generated, and we're gonna colorize the face, not the loop or things like that. You can give it a try. And now for that object, we're gonna use nodes, material. It's called none by default. It's okay. Let's go to cycles shader nodes. That's the default. It's a white color. We're gonna use attribute, of course. You already know how to do this. And the name of this is SVV color. And let's check it out when it's rendered. It's red, so it's red. It's good. It's working. It's red. It can be yellow if we have that, and then it's white again. Back to red. Just a single red is not so interesting. Really, you could perhaps add a bit of noise. Vector noise. Not 100% familiar with Blender, the Sverchok noise, but let's give it a try. So noise, kind of working. Scalar, vector. Cannot really tell. Might need a vector math. Scalar, cell noise, vector scale, vector scale noise, multiply scalar float. So Sverchok has a lot of really fancy nodes to deal with everything, like mostly vectors and lists, I think. Maybe I should separate it. I don't know if Sverchok has like a color viewer node. It doesn't have it at the moment. Maybe we can use script node or something. Vector math. Try add this. Okay. Still not what I wanted. I just want to add like a random color. You can probably do that using cycles shader node itself. So okay, we're gonna use Sverchok. The one I know that's gonna work is if we use a vector interpolation, MK3, so vector interpolations, and this is the power of Sverchok. We can have this join. This is kind of like a mixed color list in animation nodes. It's gonna be doing the same thing. So let's say we have the color red, and then we want this one's color blue, red, and blue. It has to be join level list 2, and then plug in the data there. And I believe we can have transition between the two if we plug this in, of course. So from 0 to red, vector interpolations, but we have to also supply the list of the transition number 0. Instead of a single number controlling all, we want to kind of, it can be a random number. Let's see, random, that's a random number. Plug it in. So that's a random number. Let's see, for the color, you can turn on ambient occlusion, but that's gonna slow down everything. With the cycle material, instead of the diffuse, I'm gonna change it to emit. Where's emit? Emission. So it's gonna be just the color. Okay. See, if we put a random value and plug it into this what do you call it? The strings, like a factor, F. It's gonna generate random color. So I kind of like it. In fact, we can actually mix this. If we have just a black and white or grayscale, random grayscale, and a single color, and you can have like a kind of randomized petal color. At this moment, it's randomizing the color between red and blue. So we have like a little bit of purple. Here I cannot really visualize the color this way. It's kind of guessing. Let's say if this is RGB, we don't even have the HSV, I don't think. So we could randomize the color like this. Save. The funny thing is, if you notice, so we have like 9 flowers, right? Because this is only coloring one object at a time. So say this is water lily number 1, 001. Let's switch to number 2. See, number 2 is now colorized, and then if I change the color manually we have new color and then switch to the next one. This is pretty fun as well. Actually, you don't need to worry, all the animation is still there. You can just render it out with lighting and everything. It's gonna look quite nice. Just the coloring thing is still a little bit funny now because I need to switch the object one by one. Let's hope that the Sverchok developer will create this object slot node for this. We don't need to do this manually for each flower, or there must be another way, you know, just using script node. I found this quite fun actually. Here, instead of random color, let's try another method. Instead of random, see, random is nice, but sometimes gradient kind of number is what you want. Let's say range float, and we're gonna use count. Start at 0 and stop at 1, and then count. The count number is depending on the number of petal we have here. So 1, give you that, 2, 3, 4, 5, continue. See that? You even get a interesting design like that. Surprising design result. But as if we further increase the number, we have the gradient similar color to what we have using animation nodes. Maybe that's what we want. It's very pink, doesn't matter. Let's go to the next flower. Let's just randomize this. What we're gonna get? That's a really strange looking flower color. But again, I found this really fun. Bluish. Okay, let's go to the next one. We can go quite fancy here. Instead of the face, we can use the vertex. Vertex can be also random. Vertex have it gives you this kind of interesting gradient per vertex. If you change to loop, I think loop also quite nice. Say I use a random color goes into random vector. You really can have like a really weird looking flower. There is a website by Elfnor, and she did some experiment on Sverchok and on the generator. This generative art is maybe a collaboration of Elfnor and Sverchok developers. It's really interesting way to generate like a abstract looking geometry using Sverchok, and then the way she colorized mesh is really very interesting to read. If you Google Elfnor and Sverchok, you will find that article. So with the loop, I don't know, maybe random is not the way to go. Tangent, tangent, no, don't do that. Okay, linear, cyclic, it doesn't matter really. This is also can be quite nice because we have like a gradient per leaves. This is something that can be a little bit hard to do just using cycles, shader tree. I don't know, I think if you're a Blender developer and you understand Blender inside out, you can create anything, even the OSL. The shader shader language, OSL, Blender shading language. Open shading language. If you turn that on, you can write like a shader for cycles. It's really powerful. You can make any kind of shader from like a really complex shader. Yeah, so I'm just experimenting with this. Continue on. We have 2 more flower to colorize. Yeah, that's nice. I like that. Beautiful. And last one. Should we go? What's we gonna have? Random. We did random noise. Do we have noise? Noise. Vector noise. Vector noise. Blender. New Perlin. Hopefully it doesn't crash. Okay. Save. Vertices. How many vertices do we have? Maybe I can source the vertices of this guy. Object mesh. Objects in. Yeah, let's try. Go to solid. Source that guy. Objects in. Select. Plug in the vertices. Go back to cycle render. Let's try. Get selection. Okay, get selections vector. That's a good sign. Nothing. Oh, okay, because I'm plugging it to the wrong thing. Okay, yeah. I'm kind of curious about this. Voronoi. Oh, Voronoi, nice. It's really nice. Surprise. Cell noise. Yeah, cell noise. Not very beautiful. Voronoi. Voronoi is nice. Let's skip that. This guy is kind of boring. Let's get back to number 5. Get selection. Voronoi. New Perlin. Scalar. Let's if you use scalar and then use this and then use this flower and then plug this in. So that's how we get the noise and New Perlin scalar. You can even animate it thing. Vector math. Add. You can animate this color, you know. Frame, info. It's expecting a vector in. You can animate in the Z. We're animating. If you're animating the noise over time, it's gonna change color every time. Maybe that's what you want. Yeah, but see, we get something's quite nice, very interesting looking flower, lots of variations. This is quite amazing. Maybe don't use that, just randomize it slightly. Function add add length, distance, normal, negate. New Perlin, maybe not so interesting. Cell noise, slightly better. Crackle. Blender on noise, neoperlin. Still, I think there must be a way to see the color in Sverchok. I want to have like a yellow color, so maybe have one. I'm just gonna mix it randomly. Vertices goes in, vector. Reflect angle, vector, scale, cell noise. Whatever. I think, yeah, I think so. We are pretty much done here. Sverchok will handles the color. I could just render this out. Let's add a proper coloring. Currently there are emissions. Let's switch to diffuse. That's much better. Let's give it a proper light background. Ambient, no ambient occlusions. Color, sky texture. I like the pretem rendered. Yeah, there's like a morning color. Turbidity. Maybe my computer is not powerful enough. Normally it updates real quickly. Back to Hosek. One, two. Yeah, that's okay. Not too bad, like early morning. Turbidity 5. Okay, this is like afternoon. In Australia, if we in winter, sometimes we can see this kind of color, like a purple, bluish, quite beautiful. Add a little bit of ambient occlusion, not too much, otherwise it's gonna be looking pretty flat. And just full screen it. And just wait a few seconds. Okay, so that's pretty much it. I didn't plan it to be this far, but we started from the formula Phyllotaxis thing, and then we create the nodes using animation nodes, and then we animate each of the panel growing, and then we optimize the nodes, the loop, and then with this video we learn how to bake out the flower. By doing the baking, we really simplified everything again, and we only worry about the shader and how each flower grows, like randomizing the animation itself. So I think that's the whole story. Yeah, so for this is, I think, a really good example on procedural setup. Yeah, hopefully you find this video useful, and if you do like it, please leave like or give a comment, ask me a question, subscribe to this channel, and yeah, let's see what we're gonna do next. I'm gonna see you next time. Thank you very much for tuning in.